these are all linear, so they're all lines. So if we have two lines, when we graph them, we could have two lines that intersect. We could have two lines that never intersect. And then there's one more option. Do you know what it is? Do you remember what it is? Two lines that what? Are the same. Okay, so if it is in the form of y equals mx plus b, y equals 2x minus 1, we can find our m and our b. Our b is just the y-intercept. Our m is the slope. Okay. Connect it, straight edge. The other one, it is not in y equals mx plus b. It is not in slope-intercept form. So you can change it, or I'm just going to use it in standard form. And they're going to get a little bit more complicated. So I want to show you what I would do if it's in standard form so that you can know what to do when they get more complicated. If it's in standard form, I'm going to do x and y intercepts. Remember to find the x-intercept, you just make y 0. So if I make y 0, what's the x? 5. So that ordered pair would be 5, 0. For the y-intercept, excuse me, for the y-intercept, make x 0. So we get y equals x 0, 5. Bottom one. So we had 0, 5. And those are two ordered pairs. We're going to graph those and use a straight edge to connect. When you are solving a system, the question is, what ordered pairs do they have in common? Where do they overlap? Where do they intersect? 2, 3?
Yeah.
Are you sure?
Yeah.
What if you graphed it wrong? What if you did? Well, this is going to be on a non-calculator section of the test, so putting it in your calculator really wouldn't be an option. But you can check your answer. 2, 3 should be a solution that works in both equations. So we could plug in 2, 3 to check it. You could plug it in. So we could do 3 equals 2 times 2 minus 1. So 4 minus 1. Yep, that checks. We could also do 3 plus 2 equals 5. Yep, that checks. So the ordered pair should work in both. Now this is a very easy example. They will get more complicated than that. But that's the basic concept. Okay? Now, graphing is not the best method of solving these, because what if it doesn't hit exactly on my ordered pair? Right, exactly. So where you have other methods. The first one we're going to review is substitution. The second one's elimination. You remember those methods at all? Substitution, elimination, remember hearing those? Substitution is one that you're going to be using a lot in here when they get more complicated. Elimination, I think, is the easier one. But substitution, you don't want to just skip over, because there's going to be a point where you can't use elimination. So you have to know how to do both. Substitution. What you want to do is you want to look for if any of the x's or y's have a coefficient of 1 or negative 1. You want to solve either of these equations for x or y. So I'm looking at these. Equation number 1 looks a little bit easier because it doesn't have coefficients other than 1. And you can choose to either make it x equals or y equals. It does not matter. So I'm going to make it x equals. How did I do that? I just subtracted the y to the other side. So x is equal to 7 minus y. So that means in this equation, x is equal to 7 minus y. So we're going to substitute it. We're going to do 3 multiplied by 7 minus y plus 2y equals 12. Just substitute it in because they're equivalent. And now we only have y, so we can solve for y. Distribute. Like terms. And then you're going to solve for y. I'm going to move the y over and then move the 12 over, so I'm actually doing 21 minus 12. So that y equals 9. Is that the answer? No, because the answer is an ordered pair where 2 lines cross. So that's the y part. Go ahead. Go back to the first equation. And put in y. So we're going to do x plus 9 equals 7. So x is negative 2. Is that the answer? It has to be written as an ordered pair, but how do I know I have the right answer? Okay. I would just check it in the second equation because I just got negative 2 from the first equation, and hopefully I didn't make a mistake with that one. I'm going to check it in the second equation. You can check it in both if you want, but I usually just do the other one that I didn't just use. So it does check. So now I know I have the correct answer. I'm going to write it as an ordered pair. This is an Algebra 1 content question. If you do not write it as an ordered pair, you will get it wrong. You should know it by your 4th year of math. Right? Yes. Okay. So make sure you write your answer as an ordered pair. Okay, I'm going to give you a moment to start the next one if you haven't started it yet. And then we'll go over it together, but it is the same thing. Do it by substitution. Don't use the method we haven't gone over yet. So you can get example 3. Is there a reason why you should solve it for x? You can do it. You solve it for y. There are 4 different ways you could do this. I'm not going to show all 4 ways on the board. There are 4 different ways you could substitute for that. It just depends what you did first. Instead of solving for x equals if you solve for the one that doesn't have a number in front of it, it's going to be a lot easier. Did you check that? Let me check it. Check it. It is so easy to make silly mistakes on this. Did you check your answer? Did you check it? No. Check it. Check it out, Chris. I'm going to go do the work of what I would do, but it might have been not what you did. That didn't make really. You might have solved for something different, and our work will look different. It's the same concept, but we should still get the same answer. looking at all this, I decided to take the second equation and make it y equals. That's just what I chose to do. You don't have to do the exact same thing as me. And then I would plug in that y, I would substitute that y in the first equation. So I have 3x minus 8 minus 2x is 2. So I got x equals 2. Plug it into the top equation. I got 4 for y. Check it in the second equation. And that works. So my answer, 2, 4. Yes, Jason.
Do you want to solve for like x or y? Go back to the equation where you said x or y.
You want to do substitution twice? Is that what you're saying?
No, like per second. Like right there. If you could have just gone back to 2x.
Oh, okay, I get what you're saying. Jason's asking if you can like go back to over here.
Yeah.
How we? No, because there's no y.
That's what I would.
Yeah, how'd you get y? Anytime you do go back and plug things in, for the most part, you always want to go back to the original questions when you're plugging stuff in. And when you're checking it, you definitely want to check in the original. Don't check in other forms of it. Okay. Let's move on to elimination. Whoops. Elimination is my favorite. If I have a choice, I'm always doing elimination. If I have a choice, that's usually what I do. But that's personal preference. In your assignment, I believe it says do this by substitution, and then later it says do this by elimination. Make sure you follow the directions of what it says, because that's where your points are going to be when you grade it. All right, so elimination. Elimination is the kind where you like add them up, and you either cancel out the x's or you cancel out the y's when you add them, but it doesn't happen if I just add those. So we have to do something to make it cancel. Do you remember this? You take one of them and multiply it by, well, I don't want to cancel the thing that I have to do less work for. So probably the x's. If I multiply the bottom one by what number? 5. So make sure you multiply all of the equation by 5. So our top equation, 5x minus 3y equals -2. Bottom one is now -5x plus 10y equals 15. And we add the equations together and the x's are eliminated. I divide by 7 and I get 13 sevenths. Okay, once you have that, you have 2 choices. You can either take 13 sevenths and do what we just did with substitution. You can plug it back in and find the other x, or the other variable, the x. You plug it back in. Or you could also do elimination a second time, which is what I'm going to demonstrate. But you can do it either way. You can plug that 13 sevenths in to find y, or we can just eliminate to find x's. I said the wrong thing. Eliminate the y's to find the x's. If I'm going to eliminate the y's, I need to make them both into 6's. So I'm going to take this top one and multiply it by 2, and the bottom one by 3. So you could either plug in 13/7, or you can just eliminate a second time from the beginning. And when I do the elimination, I get that x is 5/7. How do I know that my ordered pair, because this doesn't sound like a nice answer. How do I know that my answer really is 5/7, 13/7? How do I know? I can check them. I would suggest, since there is no, it doesn't say don't use your calculator. So what I would suggest is that we do check it, but by plugging into our calculator, like right over here. Like I would just do 5 times 5/7 minus 3 times 13/7 and hit enter. I would just type that in my calculator. And when I hit enter, it equals -2, so I know I did it right. You're more than welcome to do that by hand. And then the second one will be negative parentheses 5/7 plus 2 times 13/7 equals, and then you hit enter in your calculator, it should say 3, and then you know you've done it right. I'm going to ask you to do the second question there. You say 5, and then I'll go over it. But I'd like you to try it on your. So we're doing these by elimination. Did you check it? Check it. Did you calculate it? Did you? I want you to try and check your answer so that you can see for yourself what happens if you're doing it right or if you're doing it wrong. I want you to learn by experience. Did it work? Did you check it? You can do his homework. And you can do it by hand too. You don't have to type it in the calculator. I'm just saying, take it some time. Did you check it? You know, checking it's going to tell you if you're right or wrong. It doesn't tell you where you went wrong. It just tells you if you're right or wrong. Did you check it? So I'm going to work through this one because I am recording, so I would like it on there for all these absent people to to see how we work through this one. I decided to eliminate the y's by multiplying the bottom by 3. Add them together and get 7x equals -5. So x is -5/7. And then that I did not want to plug back in, so I just want to eliminate the x's instead, multiply this one by -2. I'll need to do the bottom one. So I get 7y is 17, so y is 17/7. I've already checked my answers when I did it first time, yeah. It's in my notes, you can check it if you want to. Okay, question? So the next part of your notes, we just talked about that right at the beginning. There's 3 situations when you are solving systems of linear equations. You could have no solution, you could have one solution, or you could have infinitely many solutions. Infinitely many solutions would be that they're the same line. They share all the same ordered pairs. And I'll show you what we're going to write, which is probably something you've not done before. I'll show you how we're going to answer that one. Because we're actually going to find a solution. All right, example number 6. When I'm looking at that and I see coefficients for x's and y's for all of them, I'm probably going to do elimination. If I have the choice, I'm going to do elimination. What should I eliminate? The x's?
Y's.
What should I do? Multiply the top one by -2. Because we have to have opposites to cancel out, right? One has to be negative, one has to be positive. Ooh, but what happens here? They both cancel out. They both cancel out. I can't find what x equals, and I can't find what y equals because they both canceled out. So I just look at what's left. 0 equals -9. 0 does not equal -9. It does not equal -9. Oh, it does not. So that's where we would have a no solution. You can write the words no solution, or you can learn the correct symbol for no solution. That symbol means no solution. It does not mean other things. It means no solution. Okay. You may write either. You don't write both, though. Yeah. I think you were using it for undefined at some point. I remember having that conversation with somebody. It must have been me. It means no solution. It doesn't mean undefined. All right, next one. Elimination or substitution? Oh.
Wait, the y's cancel.
Elimination? Yeah, you could do elimination. Or you could solve stuff and do substitution. I think elimination is less work because it's already ready to go. Oh, sorry. So elimination, my y's canceled out. X equals 0. But that is a number. X can equal 0. So I'm going to plug that back in. I'm not going to do elimination twice for this one. That's a nice easy answer to plug back in. So I'm going to plug that back in. 7 times 0 plus y equals 12. So y has to be 12. I'm going to check it. Just make sure. 11 times 0 minus 12 has to equal -12, which it does. So that one has one solution. Last one. You can do elimination or substitution. I like elimination, so I'm doing elimination. I'm going to multiply the top one by -2. When I add it all up, I get 0 equals 0. So I cannot solve for a variable because they all cancel out. But 0 does equal 0. So this happens when there are infinitely many solutions. This would be, both of those are the exact same line. If I graph them, they're both the exact same line. In the notes, it says to write the answer one way. In your book, it shows the answer written a different way, so I'm just going to show you both ways. This is not the answer. This is probably as far as you ever got in a previous course. This is not the answer, though. The answer is, what line is it? So we can write it in set notation. That's what's written on your paper. Set notation has the set notation has the fancy brackets that says all the ordered pairs on the line y equals, and we have to figure out what that line is. Set notation is saying for all x, y's, for all ordered pairs that are on this particular line, we have to figure out that line. So look at the original question. I need to know what y equals mx plus b is in the original question, which they're the same line, so which top one or bottom one, which one looks easier to change? Top one. Let's just make that into y equals mx plus b form. I'm going to move the y over and move the 1 back. So that's set notation. That's not how the book writes the answers, so let me show you the way the book's writing the answers, so when you look at it, you're like, oh, okay, I get it. The book writes the answers as an ordered pair. They plug in a for x, and then they find what y equals when x is a number, any number a. So it doesn't matter which equation it is, because they're the exact same. If I plug in a for x in either of these equations, what does y equal? Two times a minus y equals -1. What does y equal? What does y equal? 2y plus 1. So you can write it in set notation, which is y equals 2x plus 1, or you can write it as an ordered pair, a comma 2a plus 1. Like, it's the exact same work for either answer. It's just different notations, okay? So if you have one that's infinitely many solutions, you should have that it is infinitely many solutions, and then I don't care which way you do it. I'll put answers both ways, okay? The assignment is on your assignment sheet, and it's on the board over there, and it's up here, and there are books all over the room, so grab a book. Oh, there was an extra credit. It is the coloring. And that extra credit, because there involves coloring, is due Monday. You have like lots of extra time to do your extra credit if you choose to. If you know you're not going to do that extra credit, if you just want to hand it in and not wasting paper, totally fine. It's extra. You don't have to. But the coloring sheet is extra. You have a book or you have a book. Okay. So if you want to check out a book, you can. If you don't, I use skills for example. So I don't want to